Welcome to Spring LIB.
We are told that the block is at rest, so therefore the summation of the forces is equal to 0. Since the block is on an incline, we know that the summation of the forces in the x direction is equal to 0 and is also equal to the tension minus the mass of the block times the acceleration due to gravity times the sine of the angle the block is at. Therefore, we know that the tension is equal to the mass times gravity times the sine of theta. We know that the velocity of the wave is equal to the square root of the tension divided by the mass per meter length. We know that the mass per meter length is equal to the mass of the rope divided by the length of the rope. Therefore, we know that the velocity of the wave is equal to the square root of the mass of the block times the gravity times the sine of theta divided by the mass of the rope divided by the length of the rope. We're looking for the amount of time it takes for the wave to travel. Therefore, we know that the velocity is equal to the length divided by the time. Therefore, we know that the time is equal to the length divided by the velocity. This gives us that the time is equal to the length divided by the square root of the mass times gravity times the sine of theta times the length of the rope divided by the mass of the rope. If we square both sides, we get that the time squared is equal to the length squared divided by the mass of the block times the sine of theta divided by times the length divided by the mass of the rope. When we simplify that, we get that the time squared is equal to the mass of the rope times the length of the rope divided by the mass of the block times gravity times the sine of theta. Therefore, we know that the total time it takes is equal to the square root of the mass of the rope times the length of the rope divided by the mass of the block times the gravity times the sine of theta.